Section 5.5, example 4, using the rational theorem to find rational zeros. So use the rational zero theorem to find the rational zeros of this function. All right, so just like we did in the previous example, let's find all possible zeros. So all possible zeros. It's going to be plus or minus factors of 1 divided by factors of 2. So factors of 1 are just going to be 1, and factors of 2 are going to be 1 and 2. So that makes it easy. So plus or minus 1 divided by 1 is 1, and that's it for the numerator. 1 divided by 2 is going to be 1/2. So those are all the possible zeros. So 1 and negative 1, 1/2, and negative 1/2. So what I'm going to do is start with the very easiest version that we could possibly start with. It's going to be positive 1. Let's check to see if we have a representative for each of the terms. So our highest degree is going to be x to the power 3. So we have x to the power 3, 2, 1, and 0. Perfect. So now we could just plug this into our synthetic division. So 2, 1, negative 4, and 1. And we're going to start off with positive 1. Bring that 2 down. So we have 1 times 2 is 2, plus 1 is 3. 1 times 3 is 3. Minus 4 is negative 1. 1 times negative 1 is negative 1. And 0. So there we go there. So originally we had f of x is equal to, let's see the function, 2x cubed plus x squared minus 4x plus 1. And what we see here is x equals 1. So what we're going to do is find the 0. So set it equal to 0. We have x minus 1 equals 0. So that's going to be the 0 that we factored out. So we just factored out our x minus 1. And we're left with this part right here. Originally, this was 2x cubed. We're going down in degrees, so that tells us that this is 2x squared. So 2x squared plus 3x minus 1. There we go. And now we could factor to see what we have there. So use rational zero theorem to find the rational zeros of this function. So from here, let's try to factor it. So AC method, so we're looking for two numbers that multiply to a negative 2 but add to a positive 3. So we have the only factor is going to be 1 times 2, and 1 times 2, one of them has to be negative in order for it to be negative up here. And there's no way that we could find that just like this. So what we're going to do, since we can't factor it like normal, we're going to plug it into our quadratic equation. Because again, what we're looking for are the zeros of this function. So the rational zero. So what we're going to do is just find the zeros naturally. So with just this part of the function, because that's the only part that we can't factor, we can't really divide out right now. Let's see what rational functions we have here. So what we're going to look for is 2x squared plus 3x minus 1 equals 0. And since we have a quadratic here, we could use our quadratic equation. We could use whatever form we really want. I'm just going to go with our quadratic formula. So here this tells us that x is equal to negative b, so negative 3 plus or minus the square root of b squared. So 3 squared minus 4ac. A is 2, c is negative 1. All of that divided by 2a, so 2 times 2. And let's see what we end up getting. Negative 3 plus or minus the square root of 3 squared is 9. 4 times 2 is 8, plus a negative 1 is going to be plus 8. We're dividing all of that by 4. And it doesn't look like we have a nice root here. -3 plus or minus the square root of 17 over 4. And there isn't any way to simplify that. So we have two zeros here. We have x is equal to -3 plus root 17 over 4. And we also have -3 minus root 17 over 4. So since x is equal to those two values, we could actually factor this to be x minus 1 and two ugly values. So here we have x is equal to -3 plus the square root of 11 over 4. And subtracting it back to the opposite end, that gives us x minus -3 plus the square root of 17 over 4. And also x minus -3 minus the square root of 17 over 4. And there we go. There isn't any way to make this any prettier, but these are our factors here. If you have any questions, please feel free to ask. Otherwise, bye.